let the gustatory stimuli, all that information, and sending all that information via neural transmission, right, neural impulses into the brain to where gustation is perceived, taste is perceived. So here we are, gustatory hairs, going through those pores, ready to bind tastes as we are chewing. There's gustatory hairs, forward, our gustatory hairs. And we have our different taste sensations from sweet, sour, salty, bitter, and umami. It's one of our newest categories. This is kind of a savory sensation of taste. There's a possible sixth taste that we are associating with fats, lipids. And we perceive different tastes on different portions of our tongue. But again, to be tasted, food chemicals now, tastings have to be dissolved in saliva, and they have to be able to get down into that taste pore, or at that taste pore where those gustatory hairs are. They have to bind those gustatory hairs and then trigger the gustatory cell. And trigger an impulse in the gustatory cell that will travel into the central nervous system along the cranial nerves that are devoted to taste. Cranial nerve 7, cranial nerve 9. Okay? These are sending the information about taste to the olives of the medulla. Remember the olives? The medulla. The vagus nerve, cranial nerve 10, is sending information about taste that's coming from, there are even taste buds on our structures like our pharynx that we'll get to, and our epiglottis that we'll get to, okay? So not necessarily just on our tongue. You have taste buds kind of down the oral cavity as well. And all of these impulses are gonna be headed to the thalamus. There's our relay station that's gonna send that to different places, the gustatory cortex and the insula, the hypothalamus, the limbic system. So we're traveling along those cranial nerves. Either we're going to the olives, or we're headed to the thalamus. That's gonna relay us to the gustatory cortex and the insula, or other places to perceive, to connect smell to other perceptions. So there's that insula, know that. We can see in the brain when we taste different things, different regions of the brain light up, okay? So we know what it tastes look like when it comes to the brain activity. So different tastes provide different brain activity. And agousia is when you cannot taste, okay? So this is a homeostatic imbalance in taste. Either we have complete loss, partial loss, or distorted. So people who lost their taste during COVID, or maybe losing their taste, because COVID is still around, suffered from agousias. Okay? The taste came back. And when there's a problem with taste, there's likely a problem with smell, because they're so connected. Okay? The taste is 80% smell. Any colds, respiratory infections, therefore, are going to affect smell. And then head injuries, other things can affect smell.